Now we are going to study about next normal form, that is fourth normal form. In order to explain the fourth normal form, first of all we have to study the concept of multi-value dependency. What is multi-value dependency? Suppose you consider a simple example. Here A and B are two attributes of our relation. And here we can see that suppose that if you want to find out the relationship between the attribute values of A and attribute values of B, we can see that each value of, that is one value of A has, it is related to two values of B, that is 1 to 4, 1 to 5. But 3 is related to only 7. So here we can see the value 1 in A is related to two values of B. So it is a kind of multi-value dependency. If it was a functional dependency, the 1 will be only related to one value. Okay. So here we cannot specify if you are taking 1, it is related to two values. So this means this is the concept of multi-value dependency. If you want to explain in detail about the definition of multi-value dependency, suppose we have a relation which is called R, which consists of three attributes x, y and z. Suppose each value of x is related to a set of values in y and a set of values in z, and y and z are independent of each other. So that if such a condition exists, there will be a multi-value dependency exist inside that relation. So once again, if R is a relation which contains three attributes x, y and z, let each value of x is related to a set of values of y and a set of values of z. But y and z are independent of each other. So that is the concept of multi-value dependency. So I will show you one example. This is also it's an example of multi-value dependency, because here only two attributes we took. First one is employee and second one is dependent. If you take Smith, it has two dependent. So multi-values are there in B. Here one value of Jones also has two values in y, but Cooper has only one relation in y. So here also multi-value, that is here one value is related to more than one values in the other attribute set. So it is also a kind of multi-value dependency. Next, we have to study what is the meaning of trivial and non-trivial multi-value dependency. So before explaining the trivial and non-trivial multi-value dependency, I will show you one example table that has the multi-value dependency. Here let this be x. Suppose I am writing, we already explained the concept of multi-value dependency based on the attribute x. Suppose this is corresponding to x attribute, this is corresponding to y attribute, and this is corresponding to z attribute. Now we can check what is the concept of multi-value dependency. Here, if you are taking one value of x, 21, so here also 21, here also 21. 21 is related to two values of x, two values of y. That is, this is one value, this is another value. So one value of x is related to a set of values in y. So we are taking this attribute set as y, this attribute set as x, and this attribute set as z. In the same manner, this value of 21 is also related to two values of z also. So I am notating with another color. The 21 is related to two values of z also. The first one is dancing, 21 related to dancing. Then the 21 again, I can draw with separate the line, same line, no problem. So 21 is related to singing also. Okay. So you consider this example in which we are taking three attribute values. So student ID corresponds to x, course corresponds to y, hobby corresponds to z. And what is the meaning of multi-value dependency? If any value of x is related to a set of values on values of y and a set of values of z, but y and z are independent of each other. Here also we can say that the course and the hobby attributes are independent of each other, but only x is related to multiple values of y and multiple values of z. So that is an example of multi-value dependency. Okay. So now we can consider what is the meaning of trivial and non-trivial multi-value dependency. A multi-value dependency is normally denoted by a double arrow. Okay, if it is a single arrow, that means it is functional dependency. A multi-value dependency is denoted by double arrow. So suppose that there exists a multi-value dependency between A and B in a relation R. This multi-value dependency is said to be trivial if the two conditions are satisfied. What about the first condition? We already studied the concept of trivial functional dependency. This is the case of multi-value dependency. If this multi-value dependency from A to B is said to be trivial, if B is a subset of A. Or in other words, if we take A union B, we will get R. That is the original relation schema R. If these two conditions are, if this condition is satisfied, then we can say that our multi-value dependency between A and B is trivial. Okay, so A and B are two attributes in a relation R, which is said to be trivial if B is a subset of A, or A union B is equal to the relation R. If a multi-value dependency is said to be non-trivial if the two conditions are not satisfied. That is, if both of the two conditions are not satisfied, we can say a multi-value dependency which is said to be non-trivial. That is, B will not be, if A implies B is a relation in R, if it is said to be non-trivial, if B is not a subset of A, or in other words, if we take A union B, we will not get R. And next is, suppose D is the set of multi-value dependencies and a set of functional dependencies in a particular relation. The closure D plus is the set of all the functional dependencies and multi-value dependencies which are logically implied by D. We already studied the closure F plus in the case of functional dependency. And the same concept we are using in the case of multi-value dependency also. What is a closure D plus? If we have a set of functional dependencies and set of multi-value dependencies are given, which is denoted by this D, okay, then D plus indicates the set of all the functional dependencies and multi-value dependencies which are logically implied by D. That is, that dependencies are not specified along with D, actually they are implied by D. So they are called D plus. So now we will come to our point, that is what is fourth normal form. So we studied the concept of multi-value dependency in order to come to our point called fourth normal form. So these are the two conditions that should be satisfied in order to make a table into fourth normal form. The first one is that the table should be in Boy's Court normal form, and the second condition is that there should not be any multi-value dependency exist in a relation. So these are the two attributes that will specify the table in fourth normal form. So in order to make a table into fourth normal form, first of all we have to check whether the table is in Boy's Court normal form. And suppose this one is okay, next condition we have to check is whether any multi-value dependency exists inside the table. If there does not exist any multi-value dependency, then we can say that the table is in fourth normal form. And this is once again I repeat the concept of multi-value dependency. If there exists a dependency between A and B, that is A implies B, for a single value of A, if multiple values of B exist, there's a chance of we can say that there exists a multi-value dependency inside that relation. And we already explained this example, and here we saw that the table is already in a third normal form, BCNF. But what is the problem here? Here there exists a multi-value dependency. That is, X is related to more than one value of Y, and X is related to more than one value of Z, and Y and Z are not dependent one. That is, they are independent one. So now how we will make a table into fourth normal form? In order to make a table into fourth normal form, we have to split that table. That is, we have to write the table into like this. The first thing is that we will write the first attribute and X, that is X and Y in one table. Then we will decompose the X and Z in another table. So now our table is in fourth normal form. And this is another example, and in this example we can check whether this table is in fourth normal form. The table is in BCNF, but it is not in fourth normal form. Why? Because there exists a multi-value dependency. That is, one value of Smith is related to two values, that is xy. So it is related to two values of P name, and the Smith is related to two. Here we can see only two values are there. So Smith is related to two values of D name. The first one is John and the second one is Anna. But P name and D names are independent of each other. So there exists a multi-value dependency. So in that case, we can decompose the table into two tables. In the first table, we are taking the X and Y only. So this is the first one, which is called, we can call it as employee P name. Okay, P may be project name. And in the second table, we decompose the table which includes E name and D name only. Okay. So now we decompose tables into two subtables. Now there is no multi-value dependency. Now our table is in fourth normal form.